Hello everyone, I want to welcome you to my YouTube channel. This is Steve coming back with another video for the very basic series. So this is the book once again that we're using. You can see this in the custom thumbnail there. And this section we're going to be doing is covering a few different things. We've already continued off the screen memory, and now we're going to be continuing on into some animation, and then I'm going to go on touch on something that the book does not talk about, even though it is a very basic guide. I wanted to add this in because it's kind of in the same style of where we are right now, or the context. It's going to be redefined characters. So you'll find that interesting, and also I've already created a program. It's also got a little bit of animation in it, so we'll kind of move forward. Okay, so I have Vice open. I'm going to begin typing in some lines here. First thing we're going to do is we're going to clear the screen. If you want to know how to do this on the Vice keyboard, you just hold down the Control key and you press the Home key in the center there, and that'll create the little heart for the clear screen. And then next, we're going to be reading in some areas of screen memory that we can set up our character to. So this one is supposed to move a ball down the screen, according to the book here. So let's take a look at it. Next thing we're going to do, as we're reading in screen memory, remember it starts at 1024. It's going to be 999 bytes, or from 0 to 999, so it's 1000 bytes in total. And then it goes down to 2023 at the bottom here. So you can see it's going from the top upper left-hand corner to the bottom right-hand corner. That's what this step 41 is doing. Now, if it was just going straight down the screen, it would be a step 40. So it should be going down the screen, if I'm not mistaken here. Next, we're going to poke in color memory into that same area. So remember, we just add 54,272 plus the screen memory location to get there. And then we set a color value of 7, which I set up my color chart. So I can tell you what that is now. That's yellow. We're going to set a little loop inside of here on the next part so that we can slow it down and see it. You have to slow things sometimes down on the Commodore 64. You won't be able to see it. And set our next. And then now we're going to be doing something else. I think this might be the reverse, bringing it back up the screen, it looks like. From the bottom to the top. Set the screen color memory again. Let's double checking my lines here. I guess there are two different loops, and it makes sense, one to bring it down and one to bring it back up. Icon 32, this sets and erases the character since it creates a background color with no bits set in it, or no data set in it. And just go to 20. So I'm thinking it's probably going to be bouncing back up and down, but we'll see. And let me just save this as animation. And let's see, we're up to tutorial 9. Okay, we got it saved. And let's run it and see. Oh. It bounced it down and up, but for some reason it left data on the screen, so let's see why that happened. You saw it move though, at least, but it didn't really. I'll double check my work here. 1 second. So I just realized I changed these lines right here. 45, this is supposed to be line 40, and then 45 is supposed to erase it with the 32 background, so that will fix it. There we go. So that's going to probably go kind of slow, but you see it's a wall just bouncing off the floor and going back up. That's a little simple animation. We'll resave that again. So let's go over the lines here. So what this is doing once again is it's going from the upper left-hand corner here, which is position 1024, as we learned from the previous video. If we poke into that location there, and we'll poke in the value they have here, which is 81. You'll see the ball appear right here in the upper left-hand corner. And then it just moves it down the screen with this step 41. That just allows it to go down. Like I said, if you set it to step 40, and I'll show you here, it won't look right, but this will basically send it straight down the screen instead of, up in a corner. See how it's going down the screen now? And then it'll still do that because it's still following the other part of the program. So put it back to 41. You might be able to even do this too. Let me see if this changes anything. Okay, so we're going to try it by step 42 now and see what happens here. So it just kind of moves it over a little bit faster. Does something a little bit more interesting now. So it basically sends it over there, and then it basically jumps down at the bottom over here since it's still incrementing at 42. We'll save that as animation 2, 1.9. I tried to save the same thing, it looks like. Animate 1.9, 2, or can't do an underscore in a comma 64, so we'll do something like that, I guess. I have no idea why it's doing that, but anyways, so that's the animation. Animation is basically just taking one character on the screen as you see here, and this draws the character, the I, 81 as I showed you earlier. And then this is going to set the background color to turn it off as we learned from the previous video. This sets a delay in the loop, and this is what turns off the background color. And this sets the next, so this gets it moving down the screen as we saw. And then once it's at the bottom of the screen, you mark where it is, which is at 2009, down here somewhere. And then we begin moving it over to 1450, so we want to keep moving it over. Remember, the screen is going from 0 to 40, and from, I think it's like 0 to 25 down here. And then you're moving within those areas, basically inside the screen memory here. So basically, this is taking it from the bottom part, and we're redrawing our ball. We got to redraw it every time we put it on the screen, or the system's never going to see it again. And then you move it back up, and then changes the color memory, set the loop, and then of course you're turning it off again with 32 to move it up the screen. So you could probably set this into a bouncing ball, and they do have an example here of a bouncing ball. But to make this video as short as possible, I'm going to go ahead and cut that part out. Maybe just throw it up in the guide if you want to look at it. Yeah, I'll put it up on GitHub, but what I really want to do is I want to go into some really fun stuff I've been working on, which is redefining characters. So give me 1 second. Okay, guys, before we continue this next example, I want to explain something very important to you. So, your Commodore 64 keyboard, if you look at it here, underneath here, you can see that there's characters. Sorry, kind of bad. These characters underneath the keyboard there. If I hold it like that, you might be able to see them a little bit better. There's characters that you can hide, that are hidden under your keyboard that you can actually access. And why I'm showing you that is I'm going to show you how to go ahead and redefine those characters. Maybe not those exact ones. I'm just going to kind of get this started to show you. So I found this website, although it's in another language, but it actually has a lot of the redefined characters in here. I mean, not redefined. It has a lot of the pedaxy characters in here. So what's important to understand is that these letters are actually, I hope this is the right one. Let me just take a look here real quick. Yeah, this is it. So we're going to be redefining this character right here anyways. If I can zoom in here a little bit so I can show it to you. Right here, you see this one that shows number sign 35. We're going to be redefining that character. So each character in your keyboard and in your computer's memory are assigned to a specific number. And this number can be used to access to write into, basically. So if we access 35, which you'll see here in a minute, we're going to be able to change this number sign into something else. What I'm going to do is I'm going to change it into a brick wall to kind of lead up to the example we're going to show later, which is a really nice, I think it's a kind of a cool picture. So anyways, let me get that paused here. Okay, so now that you understand that there's a character set underneath your computer, like I said, we're going to learn how to change the character. So I'm going to type in some code here. We're going to do some simple things first. We're going to clear the screen. Kind of fancy up the colors of the screen. This is for the border color. Change it to red and change the background color of the screen here to black. That should be basic by now. And I'm just going to set a simple go sub loop in here. So if we needed to write code in between here, we could. And we'll just stop right here. So what's important now is we're going down to this line. Remember, go sub is going to that line, wherever it's going to. Think of like go sub routine. So x equals 1 to 33. So what I'm going to be doing here is I'm going to be reading in. This is actually from the the catacombs example. I was going to use a regular basic one, but I couldn't get it to work. So this is all still following. It's kind of, you know, sidetracking the book a little bit here, but I wanted to show you some cool things that I thought I could add to this. I mean, this could have just been another entire video, but I figured I really didn't have a whole lot more for this video planned tonight, or today. So we're going to go ahead and just do this. So I'll explain these commands here in just a second. Just going to enter them in for now. Now here's where we begin reading the data. And this is what we're going to do, is we're going to read in 7 bytes of this data. Like I said, and I'll go over this just a minute here. I could have paused here, but I didn't want to try to throw people off and confuse them any. Just suddenly throwing up a program on the screen without really explaining what's going on. So I figured I'd do it line by line and try to explain as much as I could. Basically right here what we're doing, and I have a little example I created here to show you. You see, this is from another example, but this is going to turn off the system interrupt right here. 5633 coming peak, 56334 and 254. And then next we're going to switch in the character ROM, which is right here, Pokemon, 1, 251. Now the SYS681 is a machine language program that's going to basically move the ROM to RAM. Remember I showed you those characters earlier. There's a lot of, there's sections in your computer memory that are devoted to your character set, and they're inaccessible until you move them to an area where you can write to. And that's what this area does right here, 14336. We're going to move them there so we can actually write the data to them. So then after we're done writing to it, we have to return the interrupts back on again. Otherwise, you won't be able to type on your keyboard. It'll lock up your program. Okay. So under the next part here, let me see. It says go to 120. So it's just going back to this line here to keep rereading this until it's done. And 140. This is the machine language data here, so I'm going to pause on this a second. Okay, so that's the machine language data right there. And that's just reading from this line right here. For x equals 1 to 33, so it's reading 33 of these bytes into memory location 680, 681, 682, and so on, so that we can store them in a machine language routine. And once we read them in here, then we're going to call the routine right here, which is basically moving the character set. This line right down here, this is, remember I showed you the 35, now we're going to redefine the 35th character. If you look at this line right here for 130, x equals 0 to 7, basically what it's going to do is it's going to read it's going to read these 7 digits here, but it's going to pay attention to this very first digit right here. And you see that right here with the first read A, so it's reading this 35A, and this A is going to be poked into here to figure out the exact location where it is in memory to change that character. So 135, and then we're going to put in our data now. And then we're going to search for a -1 in this line where it says read A. So as soon as this one of these digits has a -1 in it, that means we're done reading the data and we can quit and go back. So I'm going to run it. Actually, let me save it to be on the safe side. I'm saving it just in case it locks up. Expect that. That can happen. Fingers crossed that I had typed it in. Let me just kind of review it. Okay, so now we're going to run it. And you see it breaks out of the program. Everything looks the same, except there is one character that is different. I forgot to add in this line right here. This actually activates and turns on the redefined character set. It's basically pointing into memory where the character set is. Okay, so remember I talked about the letter 35, the number 35. So if you press this key right now, and I'm pressing the number 3 key, you can see it's changed our character. Now if we switch the mode back here, you'll see it's the number sign. So all we did is we changed this to a 30 to point to the correct character set, and there we go, we have the new character on the screen. Next, I wanted to show you how is this actually created in memory. So here's a good example, and we could recreate this character if you want to. Actually, let's do that real quick. So I went back in and I added this new line for this data character, which is a spaceship, and we'll rerun it again to show you that we've changed it into. 1 second. Okay, I just realized that this example has too many characters, so it should only be 8 down. 1, 2, 3, 4, 5, 6, 7, 8. This is actually from the Atari, and this is actually an extended character. But anyways, I just took out the lines, 2 lines, so they'll just be shortened by that, but it'll look pretty similar. So we'll go ahead and run it again. We'll hit the number key, and you can kind of see there it is. Change the color, pressing tab key number 2. We could change the colors for it, number 3, and so on. Turn off our character set again. Okay, so I'm going to go ahead and explain a little bit more here. So having these side by side here, and let me just run this again. And then create some characters on the screen there. And all I'm doing is I'm pressing the tab key to go ahead and change the colors on them. So here's how this works. The first line going across here, you can see that these represent the top part of our character here. Notice that these are in black and these are in white. So the ones that are in black, these are the bits that are on. And the ones that are in white, these are the bits that are off. Think of it that way. So anytime you set something darkened, and you could do this on graph paper, but this is darkened, this means it's on, this means it's off. So what you want to do to calculate this is like this. You notice I put numbers here at the top. These represents the, I don't know where that came from, the correct bit order of how to calculate these by powers of 2s. So we take 128, since that's the first bit lit, then we're going to add the next bit, which is 16. You notice these 2 are not lit, so we're going to this one. Then we'll add the next one here, which is 8. Number 4 and 2 are not lit, so we're just going to add 1 to finish it. And you'll see 153 is the exact result we have here. The next line does the same thing, so it's still going to be 153. There's no different change in that. And I'll calculate these out one by one if you haven't got the hang of this. So 128, again, we're going to calculate that first bit. And these days, a lot of this can be done in character pad and stuff like that. But for those who are just learning about BASIC, this is probably the best way to learn. So 128, the next character, this is a blank space, so this one is off. And then we've got 32 plus 16. It's lit, and 8 is lit. So do 8. 4 is lit. We got no space lit for 2. When I'm saying lit, meaning that it's active or on or off or whatever. But 1 is lit, and we got 189. So these 2 are going to be 189. So anytime you see it, like I said, the black area, that means that's the area you want to color in, and you want to skip over the white sections as if you were looking at it from a graph paper perspective. Because on graph paper, you're just going to see the little white lines until you fill them in, of course. Next, we're going to do the next line. The next line is pretty simple. It goes all the way across. It's always going to be 255, but I'll calculate it for you anyway to show it to you. Since they're all lit, we can just go ahead and put them in order. 255. So every bit that's lit, that means all bits are on. Then if all bits are on, then it's going to be 255 every single time. So both of these are going to be 255. The next ones are just repeating the top row, so I won't go over those again. But you can just see it's just the 189 again here. The 189, the 153, and the 153 to create our character. And that's how you create a redefined character on a Commodore 64 computer. So what I'm going to do next here to make this a little bit more fun is I'm going to show you what you can really do with these. And oh, also before we forget, let me turn this on in a multicolor mode if I can here. Give me 1 second. Okay, so what I've done here is I've showed you a few different multicolor characters on the screen here. And I went back into the program, by the way, and I added some extra lines. I think it's line 40 right there. This line right here. This is how you activate the multicolor mode. And you see it says poke 53270, which is the area where we turn on multicolor at. And then you say you poke into that same memory location, so you're basically looking and see what value's inside of there. And you're going to turn on bit 16. So in order to understand this, I actually created this on top of this original example. These are the bits. So anytime you see a bit 0, or I'm sorry, if you look at this bit right here, this 128, this bit is bit 7. This 64, as you can see up here, is bit 6. This 32 represents bit 5. This 16 represents bit 4, 3, so on. So those are how the bits are represented. And why that's important to see is whenever you see like an OR after it, this means turn on a specific bit, and it's turning on the bit for 16, and you can see that's bit 4 up here. So basically that's how you activate multicolor by mode, by initializing bit 4, and bit 4 is also going to allow you to create up to 4 colors of multicolor mode. So I do have it turned on right now, but I'm going to need to go back over here for a second and show you. So in this line here, what I did, what I did above here also is I'm pressing in the tab key and pressing the 1 key, and that will allow me to type in that character on the screen. Whoops, I think I just typed in the 1. Meant the, is it the 3? Give me 1 second. Okay, so to make this easier, I went back and I modified this program and added a few more lines in it so we can kind of see the characters here. So these top ones here, these are used by pressing the tab key and then hold. You just basically, if I had to do it right now, you press the tab key, you hold the tab key, and if you press, for example, 6, you see it turn green, and then of course you can press the number sign to change it. Press 7, you see it turn blue, and so on. That's all I'm doing for that. Now to get the multicolor, what you're going to do is you're going to hold down the control key, and you're going to press the, I'll leave the 1 key to work, let me see. Yeah, the 1 key actually does work. So there's the 1 key, and then you press the 2 key, and you hit the number sign, that's the number sign. Press the 3 key and the number sign, the 4 key and the number sign, the 5 key and the number sign, the 6 key, the number sign, and down to this line, the control 7, the number sign, and control 8 is the last one. So those are all the multicolors. You notice they don't look anything like these. It's because of how bits are set up in the computer. What you have to understand is there's a certain pattern and specific placing of the bits that creates the multicolors. Here, there's actually can be 4 possible colors for each bit pairs, and the bit pairs are represented as, think of it like binary digits like 0, 0, 0, 1, 1, 0, 1, 1. So those are basically saying which bits are turned on next to what to activate that color initially. So maybe I'll go into a whole tutorial video because I didn't want to make this one super long to trying to go over all that here. But you can also change the color modes by doing something like this with the poke locations. Let's do that next right here. So poke 53, and I'm going to turn this on so I can see this. So poke 53 to 82, for example, that controls, I put right here, that's the auxiliary color. The multicolor is the background, 53 to 81. We kind of should understand that already. And then everything else is basically auxiliary colors, and this is auxiliary 1 color. And I put up here a little chart so you can kind of see it. This is the limits of how the colors are defined from 128 to 64, as you saw earlier. It activate, the bits, and you can see the 0, 0, the 0, 1, the 1, 0, and the 1, 1. Notice when we have a 1, 1 side by side like that, we're going to get that color. With that, we're going to get that color, and so on. And that's how they're basically overlaid to get the colors that you're seeing on these screens. So we're going to go ahead and change this one. So we'll change this to a 1, and you should see, let me see, maybe a 10 will work. There it goes. You see in the background changing, because remember, you can only change certain bits. You can't change the standards. The standards are never, actually, that's right, you can't change the standards. I'm sorry about that. So I wonder why the 1 didn't work. Okay, there it is. I was like, what's going on here? Okay, so you seen it change the white. It kind of changed that area. Now, notice these are unaffected because these are not in multicolor. These are in standard mode, so those will never be changed. 2, you can see it changed it again. 3, and the whole idea is to change them until something kind of looks decent, I like to say. So there's 6, kind of a bluish. 7, like a little yellow again. And you can see all the colors in here. Most of them do have all the colors. This has, like, for example, brown. There's that brown, purple, yellow, and the background would be black. 8. So I'm just trying to find a color character that'll kind of stand out. So let's just use 1 on that one for now. And then we're going to change the next one. I'm going to leave this one on the screen so I don't scroll off the screen so we can change the next one. This is the next auxiliary color we're going to be changing, which is the second color for 53 to 83. And we're going to insert a new value into that one. Oh, same color. Can't change the same color. Okay, so there you can see it changed a little bit. Changed a little bit again. So now we got a kind of like a greenish. And these colors are represented by this section up here I put down on the chart right here. So if I'm typing in a 5, I'm setting in green color. You notice that changed to green. If I hit a 6, it should be changing to blue, just like it just did there. We'll leave that one in blue, and then we'll change the next one. I think that might have been it. Let me see. The only other thing you can really do is change the background. I don't think you can change the next one, but let me see. It wasn't in the book if it is. I don't think this one's going to do anything. Yeah, because that's not a multicolor. That's how you change the bits and the colors there. So hopefully that made sense to you. Now, like I said, I don't want to make this video super long. I hope you guys can understand how to create at least your own redefined characters. You may not understand all the multicolor stuff. That will come, and because maybe I'll do another video for it, because it tends to be a little bit more advanced, and I'd have to go through all this. I'll post this on, GitHub as always, so you can go ahead and read it yourself. But essentially, this kind of goes a little bit too far from the book, and I didn't want to vary, too far from very basic. I wanted to kind of stick and stay consistent with that. So now I'm going to go ahead and show you the example, the grand finale. Let's put it that way. Okay, so we're back, and this is going to be the example. Now, this would take a very long time to go through and explain this, but a lot of these concepts you should understand already. So let me just list it line by line here, and I'll show you. So this is clearing the screen. This is setting a variable for 200, and this is just for the score you'll see that we print on the screen here. This is going to line 1000 so that we can basically start our routine to redefine the characters. And this 510, I forget, but that's something else in the program. This is actually allowing, and what I got that on there twice. Let me get rid of that 62. This is basically it goes up the line. This is drawing the wall in the grass here. You'll see this line right here. You should be familiar with it for in the pokes. This is how it's poking in the screen memory to draw certain parts on the screen. And this is just poking. This is just doing more screen memory coloring. And remember, the 54272 is the color memory so that we can change that section. And you'll see it's all kind of the same here. It's just poking a lot of values here. This axis value, this is getting the character that's stored in there to turn this into a number. That's just kind of a shortcut to do it. This is drawing the building down here. And again, it's just poking. What this is doing here is it's going from x equals 0 to 8. So it's basically going over 8, and then it's going down 10. So you'll see a building over here, so it's drawing it like that. Basically, that's all that's doing is it's finding the correct location at 40 each time as it's going down 40, because remember, there's 40 lines across to get to the next line. And these are always going to be the characters that's being drawn. And that's according to the axis chart I showed you earlier. But these are going to be redefined characters, so you'll see here in just a second. This line right here is drawing the cars on the screen. I set a random location to draw the cars. I set this a random value here, which you'll see in the game, to kind of set a different speed. So this basically starts at 25 and it adds 15 to kind of change the speed of the cars each time. And this just draws the cars on the screen. They'll be toward the bottom here. You'll see that. This is the variable that controls the speed loop. This is going to plot stars on the screen. You'll see those. It's basically just going from here, starting at 0 over here and going all the way over to 37 in increments to step 3, so that the stars can be spaced apart. And this is setting the Y screen length, basically, or the width, whatever. Is that the height or whatever? That's showing that we want them to go down 11. We just want to print them down the screen. And this is just poking into the screen memory to make it draw the line. And first it's going to go through this first loop right here, the X to draw them over, and then the Y is going to plot them each time. And then down here, we just got more of, this is where that ghost sub went to. This is turning off the character set. This is just a line I used to turn off the character set, so we can ignore that one. But this is where we initialize the screen colors here, and we kind of read in the machine language loop. Now, there is a machine language in this program to change the character set to make it a lot faster. And I did the same thing in the example you saw earlier. I set that in there because otherwise it's going to take a lot longer and you take more chances of locking up the keyboard. But anyways, here's the data. Now, remember what I talked about the 35? You'll see it down here. You also see a 36, 37, 38. If you follow that axis chart that I showed you earlier, that's going to define, let me see if I can still find it here a second. There, I pulled it back up. So if you see right here, we've already know the 35, and then we'll see the rest of the characters here. Let me go back here a second. It went off the screen a little bit. Okay, we'll start with 37. 36 is going to be the dollar sign, but 37, which is up here, is the percent sign. 38 is the and sign. 39 is that. 40, 41, and so on. And that's how you go in and you change the characters. And here comes the grand finale picture that you guys have been waiting for. So let me just color. So I had to turn the multicolor on because I actually forgot to turn it off. Now you'll see these are the multicolor characters I created for the example. You see it drawn on the wall there. I got a little sidewalk in here. I got a little brick wall. There's the building I showed you earlier in the code. And then there's what it does. It animates two cars going down the street. The speed's going to change for the cars each time it gets back here. You'll see it's going a little bit faster now. But that's kind of the stuff that you guys can create with the multicolors. So I hope this example was good for you guys. And yeah, I'll post all this on GitHub so it's always accessible and available to you guys. And sorry if that wasn't, this was a little bit more of a confusing video, but I really wanted to show you there's a really cool thing you can do with your characters, which is changing them and making them look like something like this. Now, this is used in multicolors, you can see, because this is actually defining more colors inside here. Earlier, I didn't think it was, but when I looked at them, I noticed that there's more colors. There's a yellow, there's a black, and then there's a red in there. So there are definitely more colors in this. And you can see the cars have multiple colors on them, too. So, yep, that's all I have for this video. Please like, favorite, subscribe. As always, I appreciate your support and everything, and just looking forward to more videos. Got some exciting things coming, so should be getting my Commodore 64s back here any day now from Mitch, and I just want to say thanks, guys. Please go ahead and leave your comments and everything, any questions you have, and I'll be there to try to answer as best as I can. Take care.